Let's look at how we can use Gaussian elimination with backward substitution to solve this system of linear equations. So the first thing that we want to do is we want to write this system as an augmented matrix. So that means we're going to use the coefficients from our system of equations. So for our first equation, we want 1, 1, 1, and 6. We want 2, 3, -1, and 3. We want 1, 1, 2, and 10. So as we're setting up this matrix, the first column represents the coefficients on x, the second is y, the third is z, and then our constants are on the other side of that line. So as we're thinking about Gaussian elimination, our goal with this is to rewrite our matrix so that we have 1s on the diagonal, and then we want 0s to be down below that diagonal. So these other entries are just going to be some number, but those 1s and 0s is the goal that we're shooting for. So as we look at this matrix that we were given, it already has a 1 here, so that part is done. So the next thing that we want to work on is in column 1 to make this entry and this entry to be 0s. So we want to think about how we can use row 1 to accomplish this. So since right now in row 2, I have a 2 and I would like it to be a 0, what I'm going to do is I'm going to take row 2 and I'm going to subtract 2 times row 1 to come up with a new row 2. So let's recopy the first line because that one's not going to change. Now let's work on coming up with each entry of my new row 2. So thinking about what we're going to have here, we're saying take row 2, which is currently a 2, and subtract 2 times row 1. So this one's going to be 3 minus 2 times 1, and -1 minus 2 times 1, and then 3 minus 2 times 6. So let's simplify that and write that down. So we still have 1, 1, 1, and 6. So 2 minus 2 is 0. 3 minus 2 is 1. -1 minus 2 is -3. And 3 minus 12 is -9. Now let's work on row 3. Row 3 has a 1. We want to have a 0. So I'm going to take row 3 and subtract row 1. So let's look at our new entries. So row 3 is a 1 minus row 1 is a 1. Row 3 is a 1 minus row 1 is 1. Row 3 is 2 minus row 1 is 1. Row 3 is 10 minus row 1 is 6. So simplifying that, 1 minus 1 is 0. 1 minus 1 is 0. 2 minus 1 is 1. And 10 minus 6 is 4. So this matrix is now in row echelon form, because if we look at the diagonal, we have a 1 along the diagonal for each one of our rows, and then below those 1s we have 0s. So now we can use the information from this matrix and row echelon form to solve our system of linear equations using backward substitution. So remember that these columns represent x, y, and z. So this last row has a 1 in the z column and 0s in x and y. So this is saying that z is equal to 4. This one is saying 1y minus 3z is equal to -9. And this is saying x plus y plus z is equal to 6. So I want to take the z equals 4 and plug it in here to find y. Once I know y, I'll take y and z, plug it in here in order to find x. So if z is equal to 4, y minus 3 times 4 is equal to -9. So y minus 12 equals -9. And y is equal to 3. So now last, x plus y, which is 3, plus z, which is 4, is equal to 6. So x plus 7 equals 6, and x is equal to -1. So our solution as an ordered triple would be x, -1, y of 3, and z of 4.